this is the dielectric experiment setup what we have. So basically let us understand what is a dielectric. Dielectric is a material which is used between the parallel plates of a capacitor to increase the capacitance of the capacitor. So here I have a capacitor and I have few dielectric materials here. So these are the three dielectric materials what I have. This is glass, Teflon and acrylic. So we'll identify what is the dielectric constant of these materials. Now for that, first we'll place a dielectric material between the parallel plates of the capacitor. So here I have a parallel plate of a capacitor. So these are the two parallel plates of a capacitor and I have a dielectric. So let me place a dielectric material exactly at the center between the two parallel plates and fix it. Now this is actually a resonance method what we are doing. Here we have an option for two different materials here. One is a larger sample, the other is a smaller sample. Now we are doing it for the larger sample here. Now look at the connections here. Connection for the setup. Now we have AC supply here, then we have a resistor. This is a parallel plate capacitor between which we have a dielectric sample to be placed, and we'll find the voltage across the capacitor and also across the resistor. Now for that we need to give the connections according to the circuit given there. Here I have my capacitor. So first let us connect the capacitor here. So capacitor. Now if you look at on the board, this is the circuit what we have. Okay. Now first connect the capacitor in the place of capacitor here. Then we have AC supply to be given here. So this is the AC connection. Now I told you we have to find the voltage across capacitor and also across the resistor. So for that we will first connect this AC voltmeter and connect it across the capacitor first. So this is a connection for voltage across the capacitor. Now on this, let us switch on the power supply. And just wait until the value is shown as a maximum value. So this value is about 1.449 was a maximum value. So we'll note down the value there. This is your voltage across the capacitor. Now let us find the voltage across the resistor. For that, just replace this connection here to a resistor and interchange the AC supply. Now switch on the supply again. You'll again identify that it shows the maximum value of voltage here. Until then please wait. So you can see 0.55 was actually the maximum value. Now it started decreasing. So note down the maximum value there and switch it off. So this way you'll do it for this one sample. Same way you'll repeat it for the other samples, that is remove the samples here and replace the samples with the other sample of dielectric. Like for example we have done it for glass now. Sample glass sample with another sample here and fix it again. So once you connect the other sample here, switch on the power supply. Now we are finding the resistance, voltage across the resistor here. So note down the maximum value shown by this. Maybe it is 0.54, yeah, 545. So after this, switch off this and interchange the connections from resistor to the capacitor, because we are going to find the value of a voltage across the capacitor. Then switch on the supply again. Note down the maximum value whatever you see on the screen there. So 1.018 or 19. Maybe you can take this value also 22. So after you take the values, now see, we got Vc is equal to 1.55 and Vr around 0.545, right? So like this, we'll repeat the experiment for the other materials available, like we have acrylic and also Teflon. So noting all the values here, now we should go for the calculation of finding out the dielectric constant. So we find the dielectric constant with the formula K is equal to capacitance into the separation between the parallel plates divided by epsilon naught into the area of the parallel plate, area of the parallel plate capacitor, which is actually a circle. So now how do we find the values here is, so to find the values actually, now we need capacitance value. Now to find the capacitance value, we have the formula 1 by 2 pi F into Xc. Xc is the reactance of the capacitance. So to find Xc value is Vc by I. Vc is the voltage across the capacitor by the current. So how do we find the current? We have already noted the value of Vr. Vr divided by R. The resistance value, what we have noted in the circuit, we have the resistor here. So we are finding the voltage across the resistor. So the value of this resistor is already given to us, like on the board it is actually 100 kilo ohms. So we'll note the value of this Vr as 0.54 divided by the resistance value, that is 100 into 10 to the power of 3, because this is in kilo ohms. So we'll convert into ohms. So finding out this value, we get I value. Now substituting this I value and Vc value, what we have noted from the board, will actually find the value of Xc, that is reactance across the reactance of the capacitor. Now after you find the reactance, we'll find the capacitance value, that is C is equal to 1 by 2 pi F into Xc. Now what is this F? F is nothing but the frequency of the signal what we are giving. We have noted that F, it is an AC signal, right? So the value of this Fc value is given as 10 kilohertz on the board. So we'll note the value here. You may note whatever value is given on your boards. So this value is substituted here and we get some value of capacitance. Now we have to also find the A value, that is area of the parallel plate capacitor. So it is a circle, so obviously it is pi r square. So we find pi value is already known to us, it's a constant. So r value, that is small r, that is the radius of the sample, is actually given to us. It is actually 3.75 for the sample what we have used. Now depending on the sample what you are using, you can find the value of it. So finding the r value of it and substituting in the formula, we get the A value. So we have C value also and we have A value. Now substitute them in the formula. So the formula is C is already calculated, so substitute the C value. The distance between the parallel plates, and we also found the area value. So substituting all the values here, we have the value of K to be found here. So the K value for the glass material is found around 4.45. It's okay, like it can be between 5 to 10, but this is a little lesser value what we had. So this way we noted for all the other values, we calculate the values of A and C for all the other materials and substitute them in the formula. So you get your capacitance values, you get area values, and finally you will also get the K value. That is your dielectric constant. So this is the way you do the experiment.